Hey everyone, Nitesh this side. First of all, thank you for the 100 subscriber and sorry for the delaying of the video. Actually, I was not feeling well. So let's start with the question. So the question is word leader. Okay. So you are given a transformation sequence from word, begin word to end word. Okay. Using a dictionary word list, you have to find a path from begin word to the end word such that you have to return the number of the words in the shortest transformation sequence from begin word to the end word. And if it is not possible to make the word from begin word to the end word, you just need to return 0. Okay, so let's see with an example. Okay, so before going to the example, there need to be some constraint for this question is basically like if you choose your first correct string is BE, you can only choose the second or the adjacent string to that whichever the difference between them as a single letter. Okay, so if my string is BE, I can only choose BC or BD. Okay, I can't choose a string as AC because this is having two character of a difference. Okay, and second thing is it like you have given a word list, so it's not necessary that begin word need to be present in the word list or not, but the end word should be present in the word list. Otherwise, you can't get a final transformation from start or to the end. Okay, so let's see with an example. Okay. So let's say you are standing at here, you are standing at this point BE and you need to reach to this point KO. Okay, so what we will do, we will follow a ladder approach. Okay, so this is our ladder. Okay, so we will go by the step-by-step approach. Okay, so we will need to choose that string out of this which have the difference between this current string and in the present string have a single letter difference. So as you can see for BE, we have two options. Either we can choose CE or either we can choose ME. Okay, so let's say we choose CE. So we at here, we go step 1. So this is CE. Okay. Similarly, but we have an option for this CE. We can choose this ME also. Okay. And we can choose this CO also because these both have the difference of only one length. So let's say we choose CO. Okay. So we at now this position. So for CO, we also have two options. Either we can choose MO and either we can choose KO. So let's say we choose KO. Okay. So for with KO, we point to this. Okay. So as you can see, we start from here. We go to CE. With CE, we go to CO. And with CO, we go to KO. So this is our end string basically. What we need to return is basically how many minimum string we use to make a conversation from BE to KO. So for this case, we use 4 strings. So this is our output. Okay. So let's see other options also. Okay. So as you can see, we have several options from going to BE to KO, but we need the minimum string that we use to convert from BE to KO. So as you can see, we have this five options. So we will reject this. Now for this, we have two options, 4 or 4. We don't need to return like which path we use. We just need to return the minimum string we use. So we just return the 4. This is our output. Okay. So let's discuss or let's approach this problem how we can go with this. So as you know, this is our optimal answer. Okay. So what we can do is basically let's consider each string as a node. Okay. So this will be one node. This will be second node. This will be third node and this will be fourth node. Okay, and this transformation, let's consider this as a edge. As you already know, we have so many options to go from BE to KO, but we need the minimum or the smallest uh, string that we can take. So if you can see, this looks like a famous graph question. It's basically finding the smallest distance from source to destination. So if I consider this begin string as my source and this is my destination, I can get the smallest distance between them. Now you may ask what we can use. Like for the traversal, we can go in either direction. Like we can go with BFS or we can choose DFS also. So what we can choose? Okay. So let's say you choose DFS. Okay. So for DFS, you know in the in the tree, it will give you the shortest distance for tree because you know in the tree you have unique path for this. But if we talk in term of graph, it is not sure like you will get the unique path. It's basically you can get the exponential path also. Okay. So if you see like in BFS, we just go with the optimal approach, but DFS is not sure whether it will give the solution in one try only. It can take all the exponential part, and after that, it will give the maximum or the smallest distance that we need. So we will not choose DFS for this reason. Okay, we will go with the BFS because we know BFS will go optimally by each level to its neighborhood strings. Okay, so let's see how we can solve this problem with BFS. Okay, okay, so let's solve this problem with the BFS. Okay, so for the BFS, you already know we need a queue and we'll take one visited set also because let's say you make a you go with BE, you go to CE. Again, you have an option to choose basically BE again, but if you choose, you will go in a, let's say I choose CO. Okay. So CO, I again choose CE. So you can see this will form a cycle. So we in the question, it's already mentioned you only have to take unique string. Okay. So that's why we take a visited also. And for checking whether this is present in our queue, or let's say we have other combination also. So for checking this, we need some sort of a set or a map which can give the element in order of one, because if I search in this array, it will cause me order of n to check whether this is present or not. So for this, I will take one set. Okay. So what I will do, I will take this word array or a list into this set. So now this set will become, okay, it will be 𝗵𝘃𝗃𝗃 and CO. Okay, and now let's take a queue also. This will be our queue. Let's take a visited set also. Okay, this is our set also. Okay, so first step, what we need to check whether this KO, this end string, is present in this word list or not. If it is not present, that means we can't make this transformation, so we just return 0 from here. Otherwise, we need to do some work. Okay, so what we will do, we will take our begin word and insert this into our queue. So we will insert this here also and in visited array also, visited set also. Okay. So what we will do, we will now insert this. Now we will do loop over our queue. Okay. So what we will do, we will remove this element. We will take this in a current. This will be our current BE. Okay. So what we will do, we will make all the combination by fixing one character at each time. Okay. So if I fix this, I can make a combination like changing this AE, BE, CE till ZE because I know I only have the lowercase character. Similarly, let's say I fix this, so I have the option of this. You can say BA, BB, BC till BZ. Okay. And I also take one changes variable which will start from 1 because 1, this is our first string. So for beginning, for this I take a 1. Okay. So whenever we do this, we need to insert this into queue also, and we need to insert this into visited also. So we have so many options. So out of this, we need to check whether the option are present in set or not. So as you can see, A is not present, in the set. Similarly, BE is also not present. Now you can see CE. CE is present. Okay. So we can insert this into Q also, and we need to check whether this is not inserted into the visited set also, because if it is inserted, so we don't take this element again. Okay, so we will insert CE and we will insert into visited also. Now other option, if you can see, we just fix this E. Let's see in the set. So this we already take. You can see we have an option of ME also. We will check whether this is present in visited. No, it is not present. So we will insert in visited also, and also in this. Okay. Now check for this. Is there any option for this? See, we have fixed B. Let's see. We don't have any B yet here. So there are no option for this. So this will be for first changes. So we're done with one change. So we will increment the counter by 1. So this will become 2. Okay. Now this BE, so this CEME comes from first change. Okay. Similarly, when we do changes from this whole size, we will increase our change by 1. Okay. So let's go with the CE. So now our current will become CE. So for CE, let's say I fix this E. I have all the option like A, B, C. So let's see. I fix this E. Let's see how many options are there. So there is an option for ME. I can take this, but ME is already in the visited set, so I will not take this. I will move forward. So after this, I can say I don't have any other options. So what I will do, I will check for ME. Okay. So now current will become ME. For ME also, I will fix this E and check other option. So I have an option of CE also, which I can't take because it's already in the visited area, and other than that I don't have any option. So let's say we fix this M character now, and we change this E. So we have an option for MO and ME. ME but already visited, so we will not take, but MO we can take it. So we will insert this MO, and also we will check insert it into visited set also. Okay. So as you can see, we are done with this size, so we will increase our changes. This will become 3. Okay. I just miss one part also. So for CE, we also have the option for CO also. Okay. So we need to insert CO. After that, I have MO. Okay. So CO also there. Okay. So let's go with this size also. So now we will do for this. So we will remove this CO. Okay. So now our current string is CO. Okay, we need to first check whether this CO is equal to our end. No, this is not equal to end. Our end is KO. So we'll do our work. Okay, so for CO, we create all the combination like this. So as you can see, for CO, we have the option of MO, KO, but MO we can't take because MO is already in the visited. So we can take KO. Okay, we have take KO. Okay, so for CO, we have I guess done. Let's take for MO also. So now our string become MO. For MO, we need to check whether this is equal to end. No, this is not equal to end. So we need to make all the combinations. So for MO, I guess we have the option for KO. KO is already in the array. ME is also one option and CE also in one option, but we can't take it because that is already in the visited array. Okay. So now our change become by 1. Every time whenever we're done with one window, we will increase our changes by 1. So it will become 4. Okay. Now we remove this KO. Okay. So now our current string is KO. We need to check whether it's equal to end. Yes, this is equal to end. So what we will do, we will just return our changes. So this will return 4. Okay. You can see with other example also. So let's see within. Let's write the code for this. So as I already told you, we need a set for checking the element whether this is present or not. We are going in the correct path or not. So we take a set. Okay. After this, we need to check whether end word is present or not. So this is our base condition. If it is fail, like end word is not present, so we can't do any transformation. We just return 0. Other than that, we create our queue and inserted the begin word. So we take a queue, and similarly we take a visited, and we inserted the begin word, insert this and begin word. Okay, and we take a changes variable which start from 1, and also after this we do the loop over our queue. Okay, so what we are doing is taking the size. Size, as I already told you, we go with the window approach. Okay, so we loop over our size. So after this we take the current element, okay, and we check whether this current is equal to end word. So if it is equal to end words, we return the changes. If it is not, we need to make all the combination. Make combination. Okay, so what we have done, basically we just loop over A to Z, and we take the first character and update it, and we create a new string, and after that we need to check whether this is present in set or not. If it is present, then we only consider that string, and also we need to check whether this is also not in the visited array. Okay, so that's why we are doing ampersand visited dot contains. If it is not, we will insert in the queue also and insert it also in the visited array. Okay, and after every, you can say after every size, we like after every size loop we increment our changes. And if you don't found any, you can say any changes after this, what we are doing is basically you just need to return 0, because if there is no string that is equal to your end word, so that means there is no transformation you can make. So that's why we just return 0 from here. Okay, so let's run the code for this. So this is accepted. Let's submit it. So this is also submitted. So, and let's calculate the time complexity for this. So if you can see, what we are doing is basically loop over our queue twice. So let's say I take the queue size as m. Okay, so this will be like order of m square. And also what we are doing is we are doing for every string create the combination. So this will be order of m square n. So this will be our final time complexity for this. And space will be, we are just inserting all the word list into a set. So this will be a word list length. Okay. Hope you like this. Thank you for watching my video.